So this is what you have to focus on. When you are asked to prove that um, angles in the same segment subtended by the same arc or chord are equal, like this, then let's call them A and B. Then let's just have this as C, D. You firstly construct a center if there is no center. Then, as I was saying, you have to prove that angle at center is twice angle at circumference. You apply the concept. Firstly, you have to have dotted lines to show that those are constructions, or have them in different colors as solid lines. Then this one, I will prefer it to always be dotted. Then you have the center, which is O. Then you can label this as 1 and 2. You are allowed to do this because you are within every right to do that, since we are dealing with a circle and we know that any line from center of a circle to the circumference is a radius. So you are within your right to do that. Then from here, we can easily have A1 and A2 just to label our sketch. That is also very important. Then we have D1 here. We can call that D1. The whole of this, okay, so we can just leave it as D because it's the whole of that. Then we could focus on um, on 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 C as well. So we've got statement. So in our statement, we can easily say that we've got radius DO is equals to OA is equals to OC, and we can easily have that as radi. Then we can compare the triangles. We have this triangle one, which we can see that we've got an isosceles triangle. We've got A1, which can be equals to D. We take it like this, the whole of D. These are angles, and your conclusion should be iso triangles. For that, your reason should be isosceles triangles because we have an isosceles triangle. Then we can have here, we can write A1 here as well because they are equal. Then we can have D2 equals to D plus A1. And what's that? We have an external angle of a triangle of a tri. Then now that we have that, we are only focusing on this. Then we are going to say since we have this equals to each other, then we can write this in terms of A because we want to have this in terms of A. So this implies D2 is actually 2A1. We do the same thing for D1, which will give us, I don't know if there's something I missed here. Please tell me if there is. Okay, I didn't miss a thing. Then we have, oh, I am saying D here and I should be saying O. I think you guys can see that. This is the external angle. O2 is not D2. So we've got O here and even here O1. Then O1 is equals to 2A2. Now this proves that O is equals to 2A. Now it's fine, we have proven that. We know how to prove that. I'm just trying to show you exactly what I was expecting. You prove this, then you apply that angle O is twice angle B. That's where now the application comes in. And since we know that angle O is twice angle B, then 2A is equals to 2B. Then this is where now we conclude that these are equal. The application is here, so you have to reason that angle at center is twice angle at circum. Okay, so